Refresher on exponents. Let's start off with some notation and the vocabulary that goes along with it. A to the exponent n equals p means that a to the n is the nth power of a, and that this power is equal to p. A is the base, n is the exponent, and p is the power. A to the n is the same as saying a times a, where you've multiplied a n times, where n is greater than or equal to 2. In this case, the dot also represents multiply. We use the dot because it gets a little confusing when you start putting x's in there. You've got ax, ax, ax. It starts to look like something else is going on. There are some special cases for exponents that we should look at. A to the exponent 0 is equal to 1, so no matter what value of a you've got, as long as it's not 0, it will always be equal to 1. So even 9 to the exponent 0 is equal to 1. Any number with the exponent 1 is just that same number. A base with a negative exponent, such as a to the negative m, is the same as 1 over that number with the exponent of m, with a positive exponent in that case, again, as long as a isn't 0. So 5 to the exponent negative 3 is the same as 1 over 5 cubed, which is equal to 1 over 125. A with an exponent of 1 over n means the nth root of a, again where a has to be greater than 0 and n cannot be equal to 0. As an example, 16 to the exponent 1/4 is asking us for the fourth root of 16, which is equal to 2, because 4 times 4 is equal to 16. There are also laws of exponents. The laws of exponents allow you to perform operations on expressions written in exponential form. If you have products of powers with the same base, so you've got a to the m times a to the n, you can simply add the exponents together. For example, 8 cubed times 8 to the 4th is the same as 8 to the 3rd plus 4, which is equal to 8 to the 7th, which is a very large number, 2,097,152. The quotient of powers with the same base, so now in this case we're dividing where we've got the same base, so a to the m exponent divided by a to the n exponent. Now we subtract the exponents, so a to the exponent m minus n. Again, a can't be equal to 0. As an example, 6 to the exponent 7 divided by 6 to the exponent 3 is 6 to the exponent 4. We've simply subtracted 3 from 7 and we get 4. If you have an exponent on a product where two numbers are being multiplied together, so you've got a times b, all of that raised to the exponent m. That can also be written as a to the exponent m, b to the same exponent m, if a is not equal to 0 and b isn't equal to 0. As an example, if you've got 4 times 3 squared, that's equal to 4 squared times 3 squared, which would be 144. If you have a power on top of a power, or an exponent of an exponent, so you've got a to the m power, all raised again to the n power, you multiply the two powers together, a to the m times n, assuming a is not equal to 0. As an example, 2 to the 3rd raised to the 5th means that we have 2 to the exponent of 3 times 5, which is 2 to the exponent 15, or 32,768. Finally, the power of a quotient. If you've got a divided by b, all raised to a power of m, the m exponent can be put on both the a and the b in the quotient. So in the dividing statement, you've got a to the exponent m divided by b to the exponent m, where a is not equal to 0 and b is not equal to 0. So if you've got 2/5 raised to the exponent 4, it's the same as having 2 to the 4th divided by 5 to the 4th, which is 16 divided by 625. If you're still rusty on working with exponents and roots, you should check out the relevant Math Antics videos on YouTube. Go to my site, mrforler.ca, and click on the Mathematics MAT-504 CST link at the bottom of the page. From that page, in the Logarithms and Finance section, you'll see the recommended links on YouTube.